Hi folks, we're going to look at the second page of the worksheet from the October 20th class. Okay, so here we have a question which is pretty similar to one we've already seen. It says how many times more intense is the sound from a chainsaw at 120 decibels than a car traveling at 70 kilometers an hour at 85 decibels. Okay, so let's write out our decibel scale. Okay, so we have beta, which is the decibel level, is given by 10 times log of I, which is the intensity of the sound, over I naught, which is that 10 to the negative 12 watts per meter squared, which is the sort of our baseline for sound intensity, so the lowest intensity that can be heard. Okay, so let's go ahead and figure out what we're looking for. So how many times more intense? Okay, so that means we're comparing intensities. Okay, so let me call the one with the lower intensity I1 and the one with the higher intensity I2. Okay, so what we're looking for in order to find how many times more intense is we're looking to figure out the ratio of I2 over I1. Okay, but as we've seen before, the intensity lies stuck in a logarithm. Okay, so we're going to have to isolate the intensity from this equation here. So let's start with the first scenario. So we have 85 decibels for the car, okay, is equal to 10 log of, and I'll call this I1 over I naught. And as we did before, we can now just solve for I1. Okay, so 85 divided by 10 is 8.5, so equal log of I1 over I naught. Okay, now that we have it in the form that we'd like to, which is a logarithm equal to a number, we can turn this into exponential form. So 10 to the 8.5 is equal to I1 over I naught, and so I1 can be written as 10 to the 8.5 times I naught. Okay, and we can follow a similar pattern here now with the second one. So 120 equals 10 times log of I2 over I naught. Okay, but again, if you follow this through, okay, it won't be surprising that you can write I2 as 10 to the, well here, 120 divided by 10 is 12, so 12 times I naught. Okay, and as we saw before, that when we now put this in the equation, it didn't make a difference to have this I naught hanging around. So we didn't even actually have to replace it by 10 to the negative 12, because when we put it in the ratio, okay, we've got 10 to the 12 I naught over 10 to the 8.5 I naught. Okay, they reduce. Okay, so here we're just left with 10 to the 3.5. Okay, which is approximately equal to, let's get our trusty calculator here. So here, 10 to the exponent of 3.5 gives us about 3162. Okay, so it's about 3,162 times more intense. Okay, so quite a big range. All right, now the idea here is that we're kind of starting to see the pattern. Okay, it just involves subtracting these decibel levels in the same way that it involved, subtracting magnitudes, but you weren't subtracting the magnitudes and getting the number of times more intense. Okay, it was 10 to that number. Now you have to be careful, because here, because the decibel equation has this coefficient of 10 in front of the logarithm, it wasn't actually the subtraction of the decibel levels, it was the decibel levels divided by 10. So 120 divided by 10 is 12, and 85 divided by 10 was 8.5. Okay, so what we're going to do now is we're going to actually make this a little more general, because in fact there's an alternate formulation for how we define the decibel scale. It's certainly not the more common one. The more common one is the one we've already defined. Okay, and what it does is it comes up with a relationship between two different decibel levels. okay, without necessarily comparing it to I0, which is our baseline decibel level. Okay, so let's take a look at this one here. So the hint given is that you want to come up with an equation that includes the direct ratio of the two sound intensities. Okay, so if your two sound intensities are I1 and I2, what you want is some equation for I2 over I1. Okay, so in general, let's do what we did before, but without, just in general, if you've got some decibel level, which is equal to 10 times log of I over I0, okay, and instead of putting a specific number here, I'll just do it in general. So here, again, as we said, we have to divide the 10 to the other side. Okay, so that's equal to log of I over I0. And then we take 10, which is our base, to beta over 10, which is our exponent, is equal to I over I0. And so that means that the intensity of the sound can be written as 10 to the beta over 10 times I0. Okay, so if we go back here, okay, let's replace now, in this case here, I2 is just going to be 10 to the beta 2 over 10 times I0 over 10 to the beta 1 over 10 times I0. As before, the I0s cancel out, and here we have I2 over I1 can be written as the ratio between these two numbers. But hey, wait a minute, we've got two powers with the same base that are being divided, so I can use my exponent law and write it as 10 to the beta 2 over 10 minus beta 1 over 10. I can even bring these together if I want. Okay, and there we have it. We have an equation that involves the ratio of the two intensities. Unfortunately, this is not the best looking equation or expression that we can have. Okay, so when we actually formulate this relationship, we actually do it a little differently. You know, wouldn't it be nice to just be able to get rid of that power with base 10? Well, what's the best way to get rid of a power with base 10 is to take log base 10 of both sides. And so this is what we do. We take log base 10 of both sides. Right, and here we're just left with, again, log base 10 of 10 to this exponent. Just gives us the exponent. So we have beta 2 over 10 minus beta 1 over 10. And guess what? To clean this up, I'm going to multiply both sides of the equation by 10. So we have 10 log of I2 over I1 is just going to be equal to beta 2 minus beta 1. Okay, and this is in fact the alternate formulation for the decibel scale. Okay, the difference being that in our original formulation, okay, it was the decibel level was given with respect to some baseline sound intensity. Here it's defined as the relationship between two sound intensities. Okay, so we're comparing I2 over I1, two sound intensities, could be any two sound intensities, as opposed to comparing to that one baseline one. Okay, as you can imagine, this is not the usual formulation. Okay, but again, it's an alternative way of defining the decibel scale. Okay, so in the textbook you are going to see this version here. Okay, but the more common one is the one we defined earlier. Okay, again, what's nice also about this, the way we wrote it out, is it looks a lot like the original formula.